things here I could ask you that are labeled. Number one, those are Eli. Number two is lacteal, it's a lymphatic capillary. It helps absorb fat in the gut. Three is intestinal capillaries. The intestinal capillaries are also here over the lacteal. The lacteal is the green thing. Four, I'm not going to ask you. 15 is the intestinal crypt, and the red cells are the Paneth cells. 9 is the muscularis mucosa, that layer. So that whole layer is mucosa. This whole layer is the submucosa. I might ask you 10, which is the Brunner's glands. 11 is malt. 7, the nerve, is the submucosal plexus. This is the muscularis externa layer. You should also know 12A, the circular, and 12B, longitudinal layers. 13 is pointing to the myenteric plexus. The serosa adventitia is this outermost layer. 14 is pointing to the simple squamous epithelium of the serosa. Those layers are also shown here. Three, mucosa, submucosa, circular, longitudinal layers of the muscularis externa and the adventitia. We go to some of the mesenteries. There's a model showing you the transverse mesocolon, which attaches to the transverse colon. The transverse colon, you can see part of the tinea coli, the fat apron, or the greater omentum. The pocketed appearance of the colon is the hostra. The green tube back, that's duodenum. The pancreas shown there with the pancreatic duct showing. The main pancreatic duct. That's all I see there. Okay, so we have the stomach. We have different regions of the stomach. If you look at this picture here of the stomach, this portion right here is the fundus. But this portion around here, kind of the neck, is considered the cardia region. This region from here to here is all body. Where it starts, this point here, where it starts to flex and funnel in, is pylorus. The folds you see, the longitudinal folds, are rugae. The circular folds are plica, or plica circularis. The muscle layers are shown. This layer is oblique, that's circular, and there's a longitudinal layer out here. That's the serosa. That's all I see for these pictures of the stomach. This is the colon with the duodenum, looking at it from the back. These vessels that go over the duodenum is the superior mesenteric artery and vein. I believe that will be the inferior mesenteric vein, number 32 on this model. The superior mesenteric artery is also shown here. There's the artery, there's the vein going over the duodenum. The yellow stuff is clear. The liver was also taught, and it's a little blurry, but we can see our lobes, left, right, caudate, quadrate. We can see the porta hepatis, the proper hepatic artery, the hepatic portal vein, and the bile duct. The biliary system we learned. And so we have the gallbladder on the right side. You see the right and left hepatic duct, which merge to form the common hepatic duct. The cystic duct will then merge with it, forming the bile duct. The biliary system shown here. The right and left hepatic duct, common hepatic duct, cystic duct, common bile duct, or just bile duct. So that's the gallbladder, the quadrate, caudate. This ligament is the round ligament, or ligament of Teres. And this is our left and right lobe. That's all I see there. So here is the large and small intestine. The large intestine shows you the transverse colon, and 527 is pointing to individual hostra. The white strip is the tinea coli. 496 is the main pancreatic duct. 495 is pancreas. So 491 is duodenum. Some of the other things shown, that's the descending colon. 541 and 530 is the rectum and the anal canal. It's hard to see, but the two flexures here are the hepatic and splenic flexure, or right and left colon flexures. Other pictures of colon that show the blood supply, like this one, we can see on the model the superior mesenteric artery going off to the right, and there's the inferior mesenteric going the other way. So the superior mesenteric gives off many branches supplying blood to the jejunum ileum. It supplies blood all the way up to the left colon flexure, and you can see that the inferior mesenteric supplies blood to the rest of it. So That same model on the left is the colon. The small intestine, all of its branches have been cut here, and you can see how they would fit with that. So these models are in the classroom if you want to take a look at that. So here are the two colons of the two different torso models we have. And this one, we can see a full view of the duodenum. So we can see the vessels going over it. This is the superior mesenteric artery, there's the inferior mesenteric artery. And we can see some of the branches going to the ascending colon there and the descending colon there, each for the SMA and the INA. Now, we see other things here. This part here, the pouch is the cecum. This looks like little lips, is the ileocecal valve or orifice. So this is the end of the small intestine, specifically it's the ileum. Okay, so we didn't see that before. I'm going to move on to the kidney. Now I'll teach from the picture on the model of the kidney. You can take a close-up view. You can see that the collecting duct, from top to bottom here, is that orange structure. The pinkish structure is, what do you think, is it medulla or cortex?
Medulla.
Yeah, it's medulla or medullary pyramid. The blood supply that we can see, there's the arcuate artery and vein. This is interlobular artery and vein. It's a little bit out of view, but those are paratubular capillaries. Okay, kind of see a little bit of the paratubular capillaries. If we follow the nephron, if that's the glomerulus, that's the PCT, that's the loop of Henle, that's the DCT, and that's collecting duct. So parts of the nephron are shown in that model as well. They're more clearly shown on models like this, which we have in the room. And so if we look at the nephron first, that's the renal corpuscle or Bowman's capsule. So that's PCT. It's the loop of Henle. Remember, there's the descending thin limb and the ascending, thick ascending limb. Then it becomes around here, I will call it the DCT when it passes by the renal corpuscle. And then it's the collecting duct all the way down. The blood supply is shown on the other side. The arcuate vessels, artery and vein are shown there. The capillaries up here are going to be paratubular capillaries, but the ones down here are vasa recta. This is the interlobular artery, the afferent arteriole is shown, and the little balls of yarn are glomerulus, which means ball of yarn. Okay, here it is again on a different model. If we take a close-up view of the cortex, we see the glomerulus surrounded by the Bowman's capsule. Then that's the vascular and the tubular pole. If this is the vascular pole, what is that? Afferent or efferent? It's the afferent that is a direct branch of the interlobular artery, which is a branch off of the arcuate. This is glomerulus. This is paratubular capillary where you have the gas exchange. There's no gas exchange shown here. The nephron parts are PCT. Right there, you can see a bit of the, let me go to this picture. There's the thin descending limb, and there's the thick ascending limb. Up, I'm sorry, I did that wrong. Thin descending, the thick ascending. Then over here, I call it DCT, then it's the collecting duct. So this loop of capillaries is vasa recta. This capillary up here is paratubular. So, what capillaries are these? Paratubular. What capillaries are these? Vasa recta. You can follow the same pattern of nephron again. And this is the vascular pole. Is this afferent or efferent arteriole? Afferent. This is efferent. Okay. This is PCT, the descending thin limb, the ascending thick limb. And starting around here, when it gets all convoluted, I'll call it distal convoluted tubule. Convoluted means twisty and turny. So the white part is the collecting duct. It's labeled here for you. Here's another nephron model we have. So this one's turned on its side. You just orient yourself to 7 and 8. What blood vessels are those? Arcuate artery and vein. So therefore, is this cortex or medulla? It's cortex. Where you see, number one, Bowman's capsule or renal corpuscle. And if you do that thing where you orient yourself with the vascular tubular pole, there's vascular pole, there's tubular pole. So is that PCT or DCT? P, the beige color. Follow the PCT down the thin descending limb and the thick ascending limb. That's what a little bit 12 or 22. When it passes by there, now you start calling it the DCT. So there's more PCT than DCT, but you see the DCT is continuous with the